Welcome. Today, we're diving into the fascinating chapter of chemical history dyes. From their ancient origins to modern chemical breakthroughs, dyes have played a pivotal role in shaping culture, fashion, and even global trade. But before we talk about how dyes changed the world, let's take a look at what the world was like before synthetic dyes flooded into the marketplace.
That's right. Before discovery of the synthetic dyes, the world was a much more muted place. People used natural sources to color fabric and materials, but those colors were often limited. Think about it. Before the 19th century, the majority of colors you saw in clothing, paintings, and decorations came from plants, insects, and materials.
Exactly. You might be surprised to learn that purple, considered the color of royalty, was incredibly rare and expensive. It was made from a specific species of sea snails found in the Mediterranean called murex. It took thousands of snails to produce just a tiny amount of dye. No wonder purple was reserved for emperors and aristocrats.
And this limited access to vibrant colors wasn't just about fashion. It affected everything from art to military uniforms to trade. People's ability to show wealth, status, or even communicate important culture or spiritual values was linked to the colors that they could afford. And that's where chemistry comes into play.
What's your favorite color?
Mine's blue. What's yours?
Mine's pink.
Have you guys ever wondered where all this color came from?
Chance, what are you talking about?
I mean, look at your shirt. Look at your pants.
I never thought about that. You might be onto something.
Chance, can you tell us more?
Now let's talk about how these dyes work chemically. Before synthetic dyes, most natural dyes were extracted from plants, insects, or even minerals, but the process was labor intensive. Let's start with something like indigo, one of the oldest and most famous dyes.
Indigo was a game changer in ancient and medieval textile industries. Well, what made it so special? Well, the key molecule behind the color indigo is indigoentin. The process of extracting it from the indigo plant wasn't straightforward. You first had to ferment leaves to reduce the indigo, which made it soluble in water. Then when the dye was applied to the fabric and exposed to air, it will oxidize and turn that vibrant blue we associated with indigo.
Right, the chemistry behind this is fascinating. Indigo molecules, once reduced, bond to the fibers of the fabric through a chemical reaction. The oxidation process then locks the color in place. That's why indigo was so prized. It wasn't just the color, but the fact that the dye could bond so strongly with fibers, making it both durable and rich in color.
And it wasn't just indigo. Many other natural dyes, like the red dye from the madder plant, work through similar processes. Madder contains alizarin, a compound that binds two fibers through hydrogen bonds, giving you that deep red color. But unlike indigo, it didn't require such a complicated reduction process, though it still demanded a lot of knowledge and expertise to get the right hue.
That's right, and let's not forget the other challenge. Natural dyes were far from consistent. The color could vary depending on the plant's growing conditions, the time of harvest, and the environment in which the dyes took place. That's why it took skilled artisans to get the desired results every time.
And some of the most prized colors made from insect-based dyes, like coconut, this tiny insect native to Central America, produced chromic acid, which gives a deep, rich red. It took thousands of these insects to create even a small amount of dye, so coconut was incredibly expensive and highly sought after.
So as you can see, the chemistry behind all early dyes was sophisticated and deeply tied to the availability of raw materials. It wasn't just about color, it was just about how the dye molecules interacted with the fabric molecules to produce lasting vibrant colors.
So guys, what's your favorite juice?
I like Capri Sun. Yeah.
Really, Chance? I thought you would like chicken broth.
And I thought you liked clam juice.
Oh guys, look how bright this Gatorade is.
How do you think they're able to get that color?
Well, if we look at the label, it says it has a synthetic dye called Blue One.
I heard of natural dyes, but I never heard of synthetic dyes.
Well, I'm glad you asked. Let's talk about it. So, how did this world of limited colors transform? The answer lies in a single groundbreaking invention, the synthetic dye. It all started in 1856 with a young English chemist named Sir William Henry Perkin. Perkin was trying to synthesize quinine, a drug used to treat malaria. But in his experiments, he accidentally created a brilliant purple dye instead.
Yes, this was huge. Perkins' discovery, which was called Moavin, was the world's first synthetic dye. The beauty of this new dye that was cheap, abundant, and stable completely changed the way people thought about color. Suddenly, the color purple was no longer reserved for royalty. It was available to the masses.
And let's not forget about the way it changed the chemical landscape. Moavin was the first of many synthetic dyes, and it sparked an entire industry. People began to experiment with coal tar derivatives, yes, coal tar, which is a byproduct of coal burning, and soon we had all sorts of vibrant colors, like fuchsias, reds, and blues. These synthetic dyes were made from aromatic compounds, meaning they were made by manipulating the molecular structure of carbon-based chemicals.
Put it simply, before Perkin's discovery, getting a dye like purple was a laborious, costly process. After Perkin, colors could be mass-produced and sold at a fraction of the price, making them accessible to all levels of society. But how do these synthetic dyes work? I think I know a lot now. So let's get a little technical for a moment. Dyes work by binding to the fibers of a material, whether it's fabric, paper, or even food. The molecular structure of the dye allows it to form bonds with the molecules in the fiber, which is what gives the material its color. For synthetic dyes, this usually involves aromatic compounds, meaning they contain a ring structure of carbon atoms.
Right, and the key to synthetic dyes is that they can be produced in controlled ways. Unlike natural dyes, which could vary depending on source material or environment conditions, synthetic dyes offer consistent, long-lasting colors. This is crucial, not just for fashion, but for industries like packing arts and design. You could always count on the bright red or deep blue, no matter where you were in the world.
And let's not overlook the long-term benefits. Perkin's discovery didn't just make life brighter. The dye industry went on to support massive economic growth, leading to job creation and the development of an entire new market. For an example, synthetic dyes played a role in the creation of the modern textile industry, and by making dyes more affordable, they helped democratize fashion, but the impact didn't stop with clothing.
Exactly. Beyond the world of fashion, synthetic dyes have contributed to art, food, cosmetics, and even medicine. They've even used in everything from food coloring to drug formulations, and even in biological staining techniques in laboratories. In fact, without these dyes, the development of modern biology and medicine would have been much slower.
Looking ahead, synthetic dyes continue to play a role in sustainability efforts, too. There's a growing interest in creating dyes from renewable resources, reducing the environment impact of dyes production, and improving the safety of chemicals used in manufacturing. It's clear that the legacy of synthetic dyes is far from over.
And when you think about it, the story of synthetic dyes is more than just a chemical discovery. It's a story about how a single invention can ripple through society, changing the way we live, work, and see the world.
So, from the ancient snails of the Mediterranean to coal tar of the Industrial Revolution and onto modern-day sustainability efforts, dyes have shaped our world in ways both big and small. It's one of those quiet but powerful forces that influences everything from what we wear to how we view the world around us. Thanks for joining us today on this colorful journey.
Thank you. We hope you learned something Thank you. We hope you learned something new about the fascinating chemistry behind dyes.